Hello, welcome to the demonstration of Vulnerability Intelligence and Runtime Observability. This architecture integrates IBM Concert, Instana, and IBM Bob to automate vulnerability management and root cause analysis for enterprise applications. Bob acts as an AI assistant that takes data from scanners and repositories to generate SBOMs, following which, it uploads SBOM and vulnerability scan reports to IBM Concert. Concert serves as the central intelligence layer, correlating vulnerabilities, dependencies, and business context to prioritize risk and drive automated remediation. IBM Instana enriches this vulnerability insights with real-time observability data, helping identify which issues actually impact applications. IBM Bob integrates with Instana MCP server to retrieve application runtime metrics and identify root cause of the issue and then helps with remediation of those. Together, they enable faster root cause identification, risk-based prioritization, and automated remediation. Now, let us see how Concert application SBOM can be generated in Concert format using IBM Bob. Here we are leveraging custom mode ConcertDef SBOM, built to specifically perform Concert application SBOM generation, by taking required details such as component name, URL, image digest, etc. from provided vulnerability scan reports. This mode uses a custom Concert MCP server configuration, which provides required tools for uploading various artifacts such as applications, image scans, source code scans, VM scans, etc., to configured IBM Concert. This custom mode generates application SBOM in ConcertDef format and also a detailed report with information about the application components it has processed. Let us ask Bob to generate an application SBOM by reviewing Trivy scan reports of given container images in the current directory. As IBM Bob's custom mode is aware of the required ConcertDef schema, it generates application SBOM in ConcertDef format and also a detailed report with information about the application components it has processed. This application SBOM contains all components of application and helps us in visualizing application blueprint in IBM Concert. Let us first ask Bob to upload the generated Concert application SBOM to IBM Concert. It uses the Upload Application SBOM tool from the Concert MCP server. On approval, it proceeds further and uploads to Concert. Now let us navigate to the IBM Concert UI to view the application and its components. We can navigate to Application Inventory section and view the quote of the day application, which got created while we uploaded the application SBOM. It has 5 build artifacts, those are 5 microservices components of the application, for which image scan reports were provided. Next, let us provide a prompt for uploading all available image scan reports to Concert. It uses the Upload Image Scan tool and uploads all Trivy scan reports of application images sequentially. When completed, it generates a report with details of all upload events. We can verify the progress and status of these in the event log in the Concert UI. When all vulnerability scan reports are processed, we can view the list of CVEs in the application inventory. It can also be seen against respective image components. The details can also be viewed under the vulnerability dimension, where Concert provides insights into total CVEs and unique CVEs that need to be addressed. Now let's see how these vulnerability insights can be integrated with application runtime metrics in Instana. Let's view the quote of the day application dashboards in Instana. We have various out-of-the-box widgets such as erroneous call rate, latency graphs, etc., and we can also view the entire dependency graph of the application with respect to various microservices components, based on dynamic traffic flow. With the out-of-the-box integration, we can now view all vulnerabilities in Instana with details such Concert risk score, CVSS severity, etc. This helps application stakeholders to get vulnerability insights and runtime metrics in a single pane of glass view, which helps them in assessing priorities. Next, let's see how IBM Concert can help in providing recommendations for auto-remediation for the CVEs. Concert groups multiple CVEs and suggests which OS patch can be installed to mitigate these CVEs, based on the knowledge of the operating system advisories. Once approved, these patch installations can be performed using Concert workflows. During the next vulnerability scan workflow execution, we can verify that majority of the CVEs are addressed, and there is a reduction in total number of CVEs in the environment which Concert is managing. We can check the status of the remediation action, that is, patch installation is now success. Now let's see how we can leverage IBM Bob for smart incident diagnosis. Here, a custom mode SRE Diagnostics is used for root cause analysis of the incident. It has access to Instana MCP server, using which it retrieves application performance metrics. Let's now navigate to the application dashboard in Instana to view how all services are doing, and we can verify that there is no erroneous call in the application, and all services of the application are performing well. In the meantime, something went wrong and we can see couple of warning and critical issue alerts on the application. One can switch the time window and understand since when the erroneous calls started appearing. Even in the application dependency graph, when switching time window to last 10 minutes, it becomes evident that calls from Books API and Users API components are not reaching MongoDB component, and hence only 3 services of the application are being shown. Now, let's ask Bob to fetch erroneous call rate of the application for the last 5 minutes duration and verify the respective graph in Instana dashboard as well. After getting this metrics, we can ask it to analyze the root cause by checking Users API and Books API pod logs in the OpenShift cluster. Bob creates a quick to-do list for root cause analysis with tasks such as checking pod logs, analyzing the error patterns, and then coming up with the root cause analysis. By leveraging required OpenShift CLI commands, Bob fetches relevant application pod logs, analyses the error patterns, and provides root cause analysis for the high erroneous call issue. According to the analysis, Users API and Books API components were not able to reach MongoDB component as there is issue with MongoDB authentication. Hence Bob suggests to update the MongoDB secret with appropriate password. Next, let's provide OpenShift cluster access to IBM Bob and ask to execute option 1 to update the MongoDB credentials secret to the appropriate value. Bob performs necessary actions to rectify the issue, and we can now see that erroneous calls have stopped. In the last 1 minute there are no erroneous calls in the application. Though there are open issues in Instana, they will be soon closed after observing no error rate during the grace period. IBM Bob proceeds further and verifies all application pods are now running successfully, without any errors, and hence confirms the incident resolution with summary of steps. We have now seen how to achieve AI-driven closed-loop vulnerability intelligence and incident diagnosis using IBM Bob, Concert and Instana. Thank you.